All right, good evening, everybody, once again. So, yep, we'll continue from where we left off. So, we are supposed to implement single inheritance, right? Might take so long, that's why I'm directly getting into the content. Okay, so take an animal class and the dog class extends or inherits the properties of the animal class. So just demonstrate that class animal. Just write a small display method so that void eat, every animal eats, right? So system dot out dot print and animal eats. How about that? Okay, that's done. And class, let's do a dog class extends animal and void make sound. That's an dog box, right? System dot out dot print and dog box. That's good. And class single inheritance. Okay. Now bring the main method. Really taking a break after a long session really helps. It really refreshes. So creating a dog object. Dog. My dog is equals to new dog. So my dog can have the eat property and my dog can have the make sound property. Does that work? Right? Single inheritance dot Java. Right, that works. Singly does not singly Java, Java sing single inheritance dot Java. Right, you really cannot mess this thing up. That is like the simplest of the programs out there. Alright. 2 minutes 45 seconds and we did that. What's the next one? Multiple. That's not multiple technically, that's multi-level. So multi-level inheritance. Why don't we copy this code and make some modifications in that? Because the concept's the same, right? So, and let's do class cat extends animal and void or no, that's actually hierarchical inheritance. Hierarchical inheritance, right? I just need to look at the difference between them. Yep, that's hierarchical inheritance, what I'm trying to do. But I need to demonstrate multi-level inheritance. Class puppy extends dog. So you don't have all the properties. Void weep. You can, I think, can you overload it? I will think about it later. Puppy weeps. Weeping means crying, right? We used it without even knowing. Weeping mean. Weeping. Where is this? Okay. Shedding tears. Okay. Shedding tears. Exactly. Right. So create an object for puppy. New puppy is equals to new puppy. Right. Just a second. All right. So continue. My puppy can have all the methods. My puppy dot eat works. My puppy dot make sound. Alright, works. My puppy dot weep. That works too. And I'm saving this as okay. Okay, I need to change the name, right? Multi-level inheritance. Multi-level inheritance. Multi-level inheritance dot Java. Java. Let's do the direct compilation. Multi-level inheritance dot. Multi. Okay, it's multi-level, not multiple level. Multi-level inheritance. Is it multi-level inheritance or multi-level inheritance? Dude, what? Multi-level inheritance. Right, I saved it correctly if I'm not wrong. That is the problem with these verbose names. Multi-level inheritance. Multi-level inheritance. I don't know. Yeah, I wrote muti. Multi-level inheritance. Yeah, I wrote the spelling wrong here now. Multi-level inheritance. Come on. Okay. Sometimes you'll get satisfied after seeing an error. Okay, animal age, dog, birds, babies. Because having a slightly better error is better than not having an error. Okay, that worked, and let's continue. What's the next one? Abstract classes, okay? Abstract classes, like they have the method definition or declaration. Abstract class, that's it. Shape. Let's write abstract void area. Now everything will have its own definition, right? Just inherit that class circle extends shape. Okay, now it will have a radius. Let's write the constructor circle int. You can even give it a double if you want. This dot radius is equals to radius. Right, now let's write that area method. System dot out dot print ln the area is you can do it like this, math dot pi times radius times radius. That's pi r square, and yes, there is another bracket. That should work. Class square extends shape int side and square inside this dot side is equals to side void area system dot out dot and the area is 4 times side. That worked. And class abstract demo public static void main string of args. Okay, creating an object for circle C is equals to new circle. Let's give it the value 5 and C dot area square S is equals to new square 10. Okay, that's not 4 into side, that's perimeter side into side. Now S dot area abstract demo, right? Abstract demo dot Java. Java abstract Java. Expected comma. Okay, or a plus. Let's do the plus. That worked, as you can see. That's good. So, alright. Thanks for the reply, man. I had to force myself to code every day most of the time. Keep it to understanding the logic. My screen's not showing. Oh, thanks for saying. Alright, my screen's not showing this entire time. Wow. My bad. Yeah, I did. Did a lot of things. Alright, thanks for pointing it out honestly. I almost forgot. Right. I don't know. Was the screen not showing this entire time? I need to check it out. Ouch. Okay, let me just check it out. Okay. Wow. The screen was not showing this entire time. But that's alright. Yep, now at least we can see the screen. I did 3 programs meanwhile. Okay. So super keyword. Super keyword, okay. You just create to access the contents of the immediate parent class. This is to access the contents of the immediate parent class. Works? Right. So, yep, let's do the animal string name is equals to animal, why not? And after that we will call a constructor. All right, animal and the constructor and void makes all right, that's good. And class dog without actually, should you extend it? Yes, it will become a parent class only when you extend it, right? So string name is equals to super dot name. Okay, and dog, I'm writing the constructor. Okay, so that's the that calls the constructor void bark. Let's do it. Super dot make sound. Dog barks. You can put a backslash and say the parent method is called all right. And what do we have? You can write it as here. You can write it here as well. Dog constructor is called string type, let's say. Okay, it might get overloaded. Name one is equals to dog. I might be making things a little complicated here, but okay. Super dot make sound. That's the close of the method. That's the close of the class. And class super key demo. Let's open the main method. Right. Let's create an object for a dog and call that new dog. Okay, so system dot println d dot name on system dot out dot println d dot type. Actually, it will call these two lines first. Actually, write that. right? And D not bar. I'll change the convention over there. Super key demo.java. All right. Flexible constructors is a preview feature and is displayed by default. Enable preview to enable flexible constructors. What? Yep, just like every programmer, we are deleting the line. Let's see. Animal constructor. Is called, okay. Oh, alright, I'll ask this to ChatGPT. So, is super inside the dog? It's unnecessary because Java inserts it automatically. Okay, first line of the constructor. No, I have written that right. No. Yep. The super constructor must be first. So that's a discovery. That's a discovery. Interface is used to achieve the runtime polymorphism or the multiple inheritance, right? Method overriding, multiple inheritance, runtime polymorphism, all of this stuff are mostly similar. Ouch. So after we wrote that single inheritance, no, interface, single interface and multiple interface. And runtime polymorphism and exception handling. We will be done with this, right? Yeah, it might take another half an hour or something, but we will get this thing done. Interface demonstration. Interface, just name it interface animal. Single interface. Alright, implements is the keyword. Void make sound. Don't define it yet. So class dog implements animal. Call the dog version of make sound. Void make sound. System dot out dot print animals make sounds, right? And now you are calling the main method class interface demo public static void main string of args dog d is equals to new dog. Okay, d dot make sound. That should work. Interface demo dot java interface demo dot java make sound privileges attempting to assign weaker access privileges. Okay. Is that the problem? No, I saved it. I'm pretty sure I saved it. Make sound in dog cannot implement make sound in animal. Then we can specify. How about now? Everything must be public in interface. Is that the case? Must be public while defining to access. Okay, and learn to read errors and debugging them is important. Alright. Multiple interface implementation demo. So animal and bird. A bat is both an animal and bird, and we use that. Okay, I will check out your channel, man. Can I check out your channel? Yeah. All right. Um, multiple interface, right? Let's write an interface animal. Should I? Let's see if I should write public over here as well. So interface bird void fly. So class bat implements animal and bird. So void public void make sound system.out.println bat makes sound public void fly bat flies. So class multiple interface public static void main string of args bat b is equals to new bat v dot make sound v dot fly. Multiple the spelling's wrong. Throw me a huge ass error. You can just say I didn't find the file or the file name's incorrect, but instead Java wouldn't do that. It gives you a very huge error that will give you a stroke reading. Runtime polymorphism. So method behavior changes during the runtime. That's basically method overriding and a part of runtime polymorphism. Let's check the difference. Annotations. Okay, class animal. Yeah, runtime polymorphism is not directly achieved through that. So class dog implements animal. Public void make sound. Okay, now that I thought about it, where did I write this? Constructor or loading abstract class, right? If you can see here, I created separate objects for both of them. Actually, you can create like this as well. New circle file, right? S dot area. Now that I was thinking about runtime polymorphism, I thought about this square 10. That's not area. This works as well. Java abstract demo.java. See, that works as well. Yep, that's what I was thinking about. And we still got 30 more minutes. Or we need to complete this. Right, the exception handling and the additional programs, and we are good to go for today. The dog box class cat implements animal and the next time we got full stack development. So don't expect me to write every program of full stack development in a single day because I don't think that is going to be possible. I won't even write that. I mean, nobody asked, but I'm just saying. So, interface demo. So, we are creating an object. Animal A is equal to new dog. Can you create like that? Can you create a object for interface? I don't know. We will find out, it seems. Oh shit. What the heck? That gave me a jump scare, mate. Dude. Don't give me jump scares at night, man. Mm-hmm. Thank God. Can you create a reference to an object in interface? Printable. Okay. You cannot do like printable is equals to new printable. Oh, it's been already 41 minutes, huh? We did a runtime polymorphism, that's 15 programs plus 116 covered. Exception handling mechanism class E handling. I don't make a verbose name. Okay. Try. Right. Int array 1, 2, 3 system dot out println array of 10. It gives you an array index out of bounds exception. Array index out of bounds exception E system dot out dot println E. Alright. Caret cubic. Those silly mistakes. Java.lang. Okay, this should be able to demonstrate me the multiple catch classes. Array error. How about now? Okay. And you can also replicate the string null pointer. No, what's the name of the error? Arithmetic exception. Null pointer exception. What if you forgot that? Can you just write a generic exception? I don't know. Okay, I guess this is what I thought. If you know put parenthesis over here, that doesn't work. There can be a lot of errors in this code. I'm just experimenting. So let me experiment. Firstly, compilation failed. Cannot find symbol. It's small in URL, if I am not wrong. Error. Okay. Nice. Okay, dot length is a good method. Never mind. Okay, if you cannot remember the name of the exception, you can just write the generic exception. Okay, that built-in exception, already user-defined exceptions. That's what we are supposed to execute now. Plus invalidate exception extends exception, right? String message. Okay, invalidate exception string message. Just pass it to super, and we are good. Okay. Class demo. Okay, throw and throws are for methods, right? So void age throws invalid age exception. So yeah, you don't need to create an object for that. So is that it? No, something's fishy. No, why should you need a constructor? Okay, let's experiment. Mm-hmm. Mm-hmm. I don't expect the code to be perfect. On some errors, yes. Non-static method cannot be referenced from a static context. Okay, it is telling you. Hmm. Why is it not calling out the constructor? Okay. Yep. Yes, sir. Yes, sir. So, okay. Let's remove this. Okay, good. Alright, we got three more programs, auto boxing and auto unboxing, the multi-dimensional array. Almost we coded for 2 hours and we completed most of it, so static, right? Static, okay. So class student string name. Okay, and static call is static string call is so is equals to SIT. That's our call is. And then we have a constructor for student called so string name this dot name is equals to name. Okay, ouch. Void display system dot out dot println name plus name, right, plus exclamation call is plus call is. All right, and void change call is equals to right. Student dot change call is student s1 is equals to new student Shankar s1 dot display. Cool, cool. Auto boxing and auto unboxing, auto demo. Let's do that. Alright, int a is equals to 10, integer b is equals to a, system not out not println, auto box integer b, integer c is equals to c, int a is equals to int d is equals to c, auto unboxed integer Honestly, not Odin, not Java. Okay. Identifier expected. No, why did I do this? Yep. It was going in, auto mode. Multi DRA. Okay, 1 hour 2 minutes already. Uh-huh. Interarray. Okay, let's directly give it. Okay, that is a two-dimensional array, and that is another two-dimensional array. That works. Yep, that works. That's it, right? Okay. What the? Int cannot be converted to int. Should I always be creating object for that? Should everything be in a single line? Is that the problem? Mm-hmm. Okay, so this is a 2 Mhm. That's a 1D, and that's another 1D. So that's a close of 2D. It's a close of 1D, that's a close of 2D. So if you can see, this is 1, and this is 1, this is 2, this is 1, this is 1, and this is 2, this is 1. I don't know. What's wrong? Okay, it does not allow that, I see. Right. That's another 2D array. That's another 2D array. Closed and yeah, I will put the semicolon. Don't worry. Let's write this thing out and I will call it a day. We have made it. We have did every program today successfully and it's time for me to sleep and I will sleep. Good night everybody.